Okay, this question says a sequence x1, x2, and x3 is defined by x1 is 1 and x n sub 1 equals a times xn minus 3, where n is greater than 1. So why do we say it's greater than 1? Well, to make this a 1, then that would need to be a 0, but n is greater than 1, so x sub 0 does not form part of the sequence. So since n sub 1 sub 0 does not form part of the sequence, then we're given what the value of x1 is, so we don't have to calculate the value of x1. So the first question, well, a is a constant. Okay, find an expression for x2 in terms of a. Okay, so what we can do then is to go back to this expression, this equation, and figure out how we can find x2 from here. So if this is n at 1, this is n plus 1, it means if we make n a 1, then we've got an x2. Okay, so we're just going to say that x2 from here, let's change the color, is equal to a x, and call this one, since n is 1, then that's ax1 minus 3. Okay, I like to write the x that way, x2 equals ax1, because this x looks like multiplication. So to distinguish between a multiplying x and then just an x, I'm gonna write that one in like cursive. Okay, so the next thing is we know what x1 is. Okay, so we know what x1 is, so x2 is equal to a x1 take away 3. We're finding an expression for x2 in terms of a, which means the x has to go, but we know that, the x1, we know that x1 is 1, so x2 is equal to a minus, or a take away 3. So this is the expression for x2 in terms of a. Okay, so that's that one done. The next one is to show that x3 is a2 minus 3a minus 3. So going back to that expression again, going back to this expression, x3 means that n equals 2. So basically n, or let's call that n is a, we know that n is a 2, so 2 at 1 equals a x to the power n, which is 2, take away 3. Okay, so basically this is 3. So x3 is, let's change the color again, x3 is equal to a, but x2 we've already found. Okay, we found x2 to be a minus 3, so that's take away 3. That look more like it. Then minus 3. Now be careful because there's already a minus 3 there, so make sure that you've got the x2, which is a minus 3, minus 3 again. So x3 is equal to a squared, because it's 2 of them. In fact, we have a2 there. That should be that should actually be a squared minus 3a. minus 3. So that a2 is a mistake. This should not be a2, that should be a squared. Okay, so that's a mistake on the part of the question paper there. Okay, and then if x3 is 7, find an expression or find the possible values of a. So x3 is 7, we just make this a 7. So basically a squared minus 3a minus 3 equals 7. A squared minus 3a minus 10, because the 7 come this way becomes a minus 7. Minus 3 minus 7 is minus 10, and this is equal to 0. Now we can use the quadratic formula, which says that which says that a equals minus b plus or minus square root of b squared minus 4ac divided by 2a. Let's call this an x, just so we don't confuse it. Call that an x, where our x is eventually going to be possible values for a. Now the reason we've changed that to an x is because there's an a in here, and the a in here is actually a in here equals 1, the b is a minus 3, and the c is a minus 10. Okay, so x is equal to minus 3, because it's minus b, plus or minus b squared is 9 minus 4 times 1 times a minus 10, which changes that to a plus, divided by 2 times 1, because a is 1. So this is minus 3 plus or minus square root of 49, brilliant, over 2, which basically translates to minus 3. X equals minus 3 plus or minus 7 over 10. So x equals minus 5. Minus 3 plus 7 is 4. So x equals 2. Basically, these are the values of possible values of a, minus 5 and 2. Brilliant. So that's the end of it there. Okay, next is number 4. So here is the whole of number 3. Okay, that's all sorted. Thank you for watching, and ask me any questions if you have any.